راح نبلش بالتقديم وإن شاء الله بعدها راح تصير 9 و5.
يلا عبد الله تفضل.
تمام دكتور. مساء الخير على الجميع، أهلا بكم بالكورس المجاني المتكامل مقدم من جمعية مهندسي النفط العالمية جابتر جامعة كربلاء بالتعاون مع أكاديمية العمليات النفطية. مسك البداية راح تكون مع الأستاذ الدكتور حسين حميد احمد ومحاضرته بعنوان Oil and Gas Production Optimization. المحاضر في سطور خبرة أكثر من 39 سنة بمجال النفط والغاز وتكرير البترول، تدريب الموظفين وتقديم الاستشارات إلى الشركات النفطية، يشغل منصب رئيس لجنة البترول في الجامعة الأمريكية في الشارقة، حاصل على العديد من الجوائز منها جائزة الشرف من كلية هالتون وجائزة سيتي جيلز عام 2003 وجائزة MPE من ملكة بريطانيا عن خدمات التعليم داخل وخارج المملكة. دكتور حسين أهلا وسهلا بك بينا ويانا، وتفضل المايك لك.
شكرا عبد الله وشكرا أيضا للحضور، وأرجوك أنه صوتي مسموع والسلايدات أيضا واضحة إن شاء الله. ومحاضرتنا اليوم عنوانها بالأويل أند غاز برودكشن أوبتمايزيشن، وهي جزء من التعاون مع الSPE Chapter لجامعة كربلاء. وإن شاء الله الجماعة في SPE Chapter هم يسجلون المحاضرة ويعطوكم التسجيل مالتها، وأنا أيضا من أخلص أعطي السلايدات إلى أعطيهم لهم، يعني محمد كاظم، التواصل محمد كاظم أو الدكتور عبد المنعم، وهو إن شاء الله يوزعونها عليكم. أوكي، المحاضرة هي تقريبا ساعة ونص، ونص ساعة الثانية المتبقية هي للأسئلة والأجوبة، فإذا عندك أسئلة أما تكتبها بالشات بوكس أو تقدر ترفع إيدك وتسأل في نهاية المحاضرة. الأويل أند غاز برودكشن سيستم هو يعتبر فد integrated system، يعني متكامل. integrated يعني متكامل. You start from the beginning in the reservoir and you finish until you export the oil to the terminal. فكل المراحل هذه مرتبطة مع بعض. They are connected to each other. Starting from point A until point Z. And you do so many activities. We focus today on production. What do we do in production? And especially on optimization. Optimization فكرة جديدة هي حاليا, very new ideas, and there are so many companies asking the people to optimize. إذا تشتغل أنت بشركات نفطية, if you work with oil companies, international, they ask you for optimization of production. فالسؤال هو أول مرة شنو, what's the role of a production engineer and what's the meaning of optimization? أنا كمهندس إنتاج production engineer, what do I do? What is my responsibility? ما هي مسؤولياتي as a production engineer? production engineer عنده أكثر من شغلة, very busy. منها monitor production operations, يراقب عمليات الإنتاج اعتبارا من production tubing, wellhead, flow line, التشوك, وانتهاء بالسيبريترز. إذا مهندس الإنتاج له علاقة بعملية التصميم وتشغيل بعض المعدات السطحية والسب سيرفيس، مثلا ESB أو مثلا جاس ليفت، هذا مهندس إنتاج. مهندس إنتاج أحيانا له علاقة بالEOR Enhanced Recovery، بالwater injection مثلا أو gas injection. So these also part of him. يعمل مرات العلاقة بعملية removing the skin factor، احنا نسميها flow assurance. remove the skin factor by acidizing or fracturing. هذا يمكن نعتبره أيضا من شغل production engineer. التحديات مع البرودكشن، التحديات مثلا عملية السكين formation damage، البايب لاين تكنولوجي، السيبريترز، كل هذه مهندس إنتاج قد يشتغل فيها. مهندس إنتاج مرات له علاقة بالإيكونومكس، petroleum economics، يعني اقتصاد النفط، وإلى علاقة بالأوبتمايزيشن اللي اليوم هي محاضرتنا optimisation. optimisation عملية الإنتاج النفطي بأقل التكاليف. فهذه النقاط هي من واجبات مهندس الإنتاج في الشركات النفطية. أنت عادة كمهندس إنتاج تهتم احتمال كبير قليل من الريزرفوار، يعني في البرفوريشن اريا، البي دبليو اي، وتصعد نحو الأعلى إلى أن توصل للسيرفس. هاي كلها أنت عبارة عن production engineer. And these are important things to be aware about. هذا production system in front of us. أنت كمهندس إنتاج اسأل نفسك what are the factors could be affecting on my production. أنا أعطيك مقدمة سريعة وبعدين أدخل على الأوبتمايزيشن. Ask yourself as a production engineer what are the factors affecting me. منها I need to know the reservoir fluid properties، خواص النفط الخام والغاز كذلك، such as API, viscosity, chemistry of it and so on. أريد أعرف الصخور porosity and permeability, my rocks as well. أريد أعرف الانتراكشن ما بين rock and fluid, such as wettability, adhesivity, saturation, and these are important as well. Capillary pressure. These also عبارة عن interaction ما بين الصخور والcrude oil. I need to know what's my production design criteria. Shall I produce from a choke, tubingless? Shall I do ESB? Shall I use a gas lift? Shall I have a choke or no choke? هاي يسمونها production designing criteria. You should know this one. And I should also monitor the production history قبل ما أبدأ وبعد ما أبدأ. That production history إلى علاقة بال pressure depletion, the flow rate depletion, GOR increment, water cut increment. فهي كلها مهمة كمهندس إنتاج أن يأخذ اعتباره، وهي عوامل تأثر على الإنتاج. So if somebody asks you, name for me factors affecting on productions. ما هي العوامل اللي تأثر على الإنتاج؟ هاي أمامك 5 عوامل، 5 أشياء تقدر توسع بها أكثر وأكثر. أيضا الفاكتور الأخرى اللي يأثر برودكشن هو الدمج، نسميه flow assurance، الفورميشن دامج، مرات بنسميه skin factor positive or negative. I need to know the IPR, Inflow Performance Relationships. إذا تذكر Vogel's equation لها علاقة ب البرودكشن. لازم تعرف شلون تحسب البرودكتيفيتي اندكس والانترسبت ما بين انفلو والاوت فلو. هاي كلها عوامل عليك ان تفتهمها اثناء البرودكشن. هذه مقدمه سريعه. بس السؤال هو what do you mean by يعني production optimization؟ ماذا تعني كلمه optimization؟ Optimization in simple term هو عباره balance between production rate and delivery depending on demand. يعني قد انتج انا in my wellbore، قد انا اوصل السيبريتر and what is the demand from my company. يتطلب منك optimization. You should know your system, production system and your reservoir fluid. البرودكشن سيستم شنو يشمل؟ البرودكشن سيستم يشمل البوتوم هول بريشر البي دبليو اف، البرفوريشن اريا، البرودكشن تيوبينج from bottom up، ال SSSV subsurface safety valves، الريستريكشن داخل التيوبينج، الويل هيد، الفلو لاين، التشوك والسيبريتر. كلها مع بعض راح نسميه فلو سيستم او برودكشن سيستم. فالبرودكشن سيستم يشمل اشياء سب سيرفيس وسيرفيس. Let me show you. This is it. شوفوا هاي سلايد شباب. Do you see slide? You are with me? اكبرها.
نعم دكتور.
هسه كبرت صارت كبيره امامكم. هذا كله مع بعض نسميه برودكشن سيستم. اذا واحد سالك في جوب انترفيو قال لك شنو برودكشن سيستم؟ ما هي مكوناته؟ انت تنزل له من اسفل البئر، تبدا من بي دبليو اف وتصعد نحو الاعلى. تقول البي دبليو اف، تقول له الالت اوف ذا برودكشن تيوبينج، الريستركشن اوف ذا برودكشن تيوبينج، السب سيرفيس سيفتي فالف، الويل هيد بريشر، التشوك، الفلو لاين، السيبريتر، كلهن مع بعض نسميه احنا production system. So the production system has some parts which is subsurface, while the other parts are surface. جزء سطحي وجزء تحت السطح. All these are important to think about it. So the optimization, I need to deal with the system in a way that with minimum problems and maximum production with a good quality. ما عندي مشاكل، مسيطر على كل شيء وينطيني الإنتاجية اللي أريدها. So can I make this system work optimization بشكل مثالي؟ What shall I do؟ مثلا واحد يجي يقول لك والله يختار التشوك سايز يكون مناسب فوق. واحد يقول لك والله أنا أختار I will choose the right production tubing. Somebody else will say to you I will choose the number of perforations. شخص آخر يقول لك I will put an ESB or a gas lift. So, or maybe I will use a bigger separator, and so on. So the system, you take it piece by piece, and then you say I need to optimize them. The most important things in the system is to understand the pressure behavior. The pressure is very, very important to control and to monitor. Starting from the external pressure, average reservoir pressure, the PWF before perforation and after perforation. The PWF before perforation قلنا يسمونه PWFS. هذا S for sand phase، يعني اللي هي الصخور. PWF inside the well bore. بعدين عندك pressure friction losses inside the tubing. عندك pressure in the wellhead. You lose the pressure نسميه هنا outflow. With pressure losses in the flow line. In this system, I have two types of flow, two types of oil flow. One of them I call inflow, I-N flow, F-L-O-W. وعندي outflow, the flowing of oil inside the porous media نسميه inflow. وهذا يخضع إلى Vogel equation, IPR. والفلو inside the well bore through the tubing يسمونه outflow. So I have inflow performance وعندي outflow performance. عندي IPR وعندي OPR. والinteraction between them will give me a good optimization. Give me the right and the best and the most optimum operating point between the flow, choke, and tubing. So remember this system and remember how much pressure we are losing as we go from underneath up. كل ما صعد نحو الأعلى we lose delta B. عندي 1 2 عندي 8 delta B. I have 8 pressure losses. 8 pressure losses. I lose pressure in 8 areas, in 8 locations. If you understand this slide in front of you, this is the beginning to understand optimization. This is the beginning of production system optimization. تسأل نفسك تقول أنا شلون أقدر أخلي losses of the pressure to be minimum? I lose the pressure is not good for me. فمثلا أنا ما أريد أخسر pressure ما بين الويل هيد، مثلا الويل هيد والسيبريتر. I don't want to lose too much pressure. فتقول maybe flow line diameter, smoothness, maybe single phase or multi-phase, maybe the choke size open or not open. And this is the idea. انت كمهندس optimization, you sit together, you sit with yourself and tackle every delta B. انت اسال نفسك ليش هاي الدلتا بي اقدر اسوي هاي الدلتا بي to the minimum. You cannot make it zero, impossible, but to the minimum. I reduce it. I reduce the pressure which I'm losing, and that will be a good way to understand, which I will explain later on in a minute. But let me continue talking about optimization. So we know the meaning of optimization from this slide, and now the production system include. هذا production system here in front of you include the reservoir, الصخور. So you are reservoir production engineer. Production engineer, he or she must have a good underpinning knowledge regarding the reservoir. And that's important. So you have to understand reservoir engineering in order to understand production later on. So you have to remember flow in porous media, a pressure drop in reservoir formation, Darcy equation, سواء كان steady state flow or semi-steady state or pseudo or unsteady states. You need to know these things. So production system needs from something about a reservoir, حنسميه IPR. IPR اتذكر فوجل equation. أنا متأكد درسوكم بالجامعة وبعضكم يعرف الفوجل equation. يشمل الويل بور، يعني التيوبينج والكومبليشن مالتي. Single, dual, multiple completion, a tubing with no pump, no artificial lift, a tubing with artificial lift such as gas lift or ESB. هاي كلها مهمة عندك production system optimization. بعدين تجي للسيرفيس فاسيلتيز مثل السيبريتر، فلو لاين، البايب لاين، الفالفز and so on، tanks. فكلها مع بعضها تكون هو system. فأنت عندك something we call subsurface and you have something surface as well. Sometimes it could be very simple, sometimes be very complex depending on the reservoir condition. So simple when we have maybe simple reservoir, tubing surface facilities. Complex if I put artificial lift system or maybe water injection, or I have multiple well, multilaterals, dual completion, triple completion. This is more complex. So this is the idea of optimization. Optimization مطلوب من عندك. You should know the production system مالتك. Production system أذكركم من جديد هذه السلايد مالته. This one. So you need to know that very well. And you say it's complex or not complex. So in this system or this slide in front of you, we have a good understanding. We start from PE ونخلص بالPSEP. We start from PE يسمونه external pressure. And you finish with PSEP, it is separator pressures. وشوف الbehavior ماسن. So therefore, to understand a production in proper way, you need to understand reservoir deliverability. Deliver يعني يوصل. Reservoir which is can give me oil. Deliverabilities. when يوصل من الصخور إلى داخل well bore. From PR until we reach PWF. نسميه هذا reservoir deliver. The reservoir delivering oil to the well bore, to the bottom hole of the well bore. بعدين شنو أريده من عنده؟ أريد lifting، أرفع الأويل من هنا من PWF إلى أن أوصل للسيرفيس. And see lifting of the hydrocarbons. How does we lift the hydrocarbon? Maybe by natural pressure, maybe by using artificial lift. Give me example, ASP, gas lift. Maybe I have very small pressure. Then what shall I do? I say water injection, chemical injections, and نسميها EOR, enhance or recovery methods. بعدين الاويل من يوصل للسيرفيس وقت سويته you need to go to send it to the stock tank, the tank before exporting the oil, before sending the oil to a refinery or to abroad other countries. فأنا عندي هنا نقطة سميتها transport to marketplace. Also, this thing you need to consider as part of optimization. A flow assurance. يعني شنو flow assurance? The flow مالتي, this flow in the well bore will never stop. Continue every day is give me a flow rate. يعني أنا production well is working every day, 24/7, 24 hours, 7 days a week. When it will stop if we have problems, such as a broken ESB, or maybe gas lift valve is blocked, or I have blockage with the production tubing because of scale build-up and asphaltene. Maybe I have perforation blockage. I have formation damage. نسميه skin factor. هذه لها علاقة بالflow assurance. So I have to make sure that my flow assurance is continuous. عندي formation damage, so I'm thinking how to remove it. Maybe by acidizing, fracturing, solvent injection, sand production, so sand clearance, wash out the bottom of the well bore, and the blockage with the tubing, so I have to open the tubing, maybe acidizing, or maybe solvent injections. That is the word of flow assurance, number 4. Number 5, with consideration, think about the oil market. Is it worth it? If the price in the market is very good now, so to make me happy and to spend more money on my oil well, or the oil price is not good, so you need to think about the market. Last week, I gave a full training course on petroleum economics. And I talked to my trainees about the oil price and the factors affecting on it, and the time now is good for making money because of the oil price is useful. So remember, you ask yourself, what do I need to consider to make this production system optimized? كلمة optimum بالعربي يعني مثالي, typical, example, very good. I speak sometime in Arabic because most of the audience are Arabic, or they speak Arabic or understand Arabic. So these 5 important factors in consideration. اكتب ملاحظة, سجل ملاحظات تفيدك هذه المعلومات. أجي على this reservoir deliverables. بين قوسين افتح قوس هنا واكتب عليها Darcy equation. I mean Darcy equation. I mean flow in porous media. That's what I mean in point number 1. Is my reservoir easy to flow through it? A good permeability, a good porosity, a good pressure drop, or it is heterogeneous and difficult to flow? فالنقطة الأولى, if you want to understand production optimization, you should have some understanding for your reservoir, at least Darcy equation, point number 1. In point number 1, you ask yourself about reservoir fluid flow. The fluid flow through porous media. بين قوسين Darcy equation. Is my flow a steady state or pseudo steady state or semi steady state? Is it single phase or multi-phase? And that's important. My flow regime, is it linear? Is it radial, spherical? Reservoir geometry, is my reservoir dip angle? Is it a large reservoir? Is it with water aquifer? Water derived mechanism? Gas cap? Geometry of my reservoir, is it a piece of rock or is it sand lenses? Whatever it is, all these geometry. And finally, number of flowing fluids in the reservoir. Inside the reservoir, do I have only one single phase or a liquid, or liquid with gas? Number of flowing fluids, or liquid also segregated into oil, water, and gas. So you need to understand these things. Even you, to be a good production engineer, you should have a good knowledge of reservoir fundamentals. شباب اسمعوني؟ Are you there؟
نعم دكتور.
شكرا. انا ما امامي فقط السكرين بتاع اللابتوب مالتي، يعني اذا تروحون انا ما ادري، بس اتكلم نفسي يعني. And happened with me many times. Sometimes I talk 1 hour وبعدين اقول ماكو واحد يسمعني. Okay, so this is important to keep in mind. إذا كنت عبد الله من SBA chapter، إذا يعني I lose contact with you, just you can either contact me by WhatsApp or shout something. So the flow regime you need to understand. مو صعب، يعني not something very very complicated. أنت افتهم دارسي equation flow in porous media وتقول هالفلو مالتي هو عبارة عن يعني semi steady state unsteady state، يعني dV by dt constant low variables or something like that. شنو كلمة steady state and semi steady state؟ إلى علاقة بما يسمى dV by dt drop with time. إذا أنا عندي for example compressible fluid he mean gas. هاي كلمة إذا تقرأ بكتب معينة وقال لك compressible fluid بين قوسين he mean gas flow. Gas equation. Slightly compressible يسمونهما gas condensate. الاسم الآخر إله. Incompressible mean oil or water. So these are the meaning of the fluid I have, either oil or water or gas condensate or gas. أنا أجي على steady state مثلا. The steady state where we have incompressible fluid, that means liquid, we use the linear equation. This is the equation of Darcy, which is come like that, as a linear equation. Darcy linear equation. Darcy linear equation. Very simple equation, but important to understand how does the oil move inside the rock from the outside to where the wellbore. وسميناها IPR, capital I, capital P, capital I, R. Inflow performance relationship. Relationship between what? Between flow rate and delta P. Between Q and pressure. So that's a linear one. نسميها steady state because dV by dt is equal to a constant. هذا steady linear، هذا steady state radial. This is the same Darcy equation, but we modified to radial where we have ln RE over RW. وأنا متأكد أنتم إذا طلاب صف ثالث أو رابع petroleum engineering you came across Darcy equation. إذا أنت geology همين قريت Darcy equation. Linear and radial. And this is steady. A steady state means dB by dt equal to a constant figure. Incompressible, يعني for liquid as well, you can rearrange هذا Darcy equation as a subject of pressure. وشوف علاقة البريشر مع اللوكيشن away from the wellbore. وشون البريشر كل ما أجي قريب من الويل بور البريشر يقل 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 إلى أن يصبح عندي قليل جدا نسميه PWF. فإذا واحد سألك سؤال أنا أسألك سؤال، منو أكبر؟ what is more larger in value؟ ال PWF ولا ال PR عادة؟ منو أكبر دائما؟ المفروض الجواب ال PR دائما أكبر، reservoir pressure دائما أكبر. هذه فاكت. الفاكت عندي أنا دائما إنه ال PR average reservoir pressure هو أكبر بكثير من ال PWF ال well flow pressures. And that's important. هو عبارة عن PWF plus other factors need to look into. يعني ال PR إذا مثلا نقول PR 2500 PSI ال PWF يمكن 1500. سؤال لكم، أنا عندي ال PR هنا ال PR هذا بهالسلايد 2500 ال PWF 1500. وين راح الألف؟ Why I lost 1000 PSI? Why؟ أنا عندي 2500 ومن وصل الأويل داخل البير صار 1500 from 2500 to 1500 PSI. So where I have delta B equal to 1000 is gone away. I lost it. Why? The answer because of the restriction of flow in porous media due to friction losses, and we have a narrow channeling in the rocks. So I lost the pressure. شلون أقدر? How can I make that pressure losses minimum? قليل. You say maybe I have better perforation. I do acidizing. I do hydraulic fracturing. يعني I create channels within my rocks to make restriction is small. Then this is the things you need to think about as well. That relationship between a pressure and location, هنقول P is function of R. You may finish with a curve like that. So عندك انت 2500, this is the PE pressure or reservoir pressure. As you come to the well bore, it's 1800. So I lost about 700 PSI due to friction losses within the body of the reservoir. هذا radial incompressible fluid, radial oil flow. Then أول واحد سميناه steady state flow. النوع الثاني يسمونه unsteady state flow. These are important in understanding the optimization later on. So the single phase in porous media, خلينا نقول oil through porous media or gas through porous media. Porous media information. In unsteady state flow عندك الدي باي دي تي مو constant متغير. So remember شباب بالsteady state flow عندي أنا الدي بي over dt يساوي فد constant. مرات يكون يساوي صفر وما يساوي صفر بيساوي very small constant. يعني pressure depletion with time إلى حد ما ثابت. In the unsteady state flow لا ال d by dt is a function of I and t. I هو ال position or location, where are you away from the wellbore. ال I هو ال position. ال position يعني موقعك جد بعيد أو قريب عن ال wellbore. How you are far away from the wellbore. هذا ال I. ال T is with time. يعني with time the pressure will deplete. So عندك two function أو two factors affecting on the dB by dt بال unsteady state هو ال position and the time. Function of يعتمد على where is your position, how far away you are from the wellbore, and at what time you are measuring that. In the beginning of flow, middle of the flow, after a certain time of the flow. So that time factor. The unsteady state is important to think about. The unsteady state, or steady states, will be affected by the pressure affected by permeability, porosity, flow viscosity, and rock fluid composition. These factors لها علاقة بال dB by dt. These could have a connection with pressure distribution. So always remember بالsteady state عندي dB by dt أو ثابت، unsteady متغير. استخدم دراسي equation radial linears، والفاكتور affect على fundamental reserve fluid in general سواء كان steady and also إذا كان unsteady in both cases، يعني سواء steady or unsteady. الثر ب permeability, porosity, fluid viscosity and rock and fluid properties or compressibilities. كل ما يكون عندي permeability كبيرة my dB by dt will be very small. الviscosity عالية my dB by dt will be large as well. I lose more pressure. This is the يعني distribution of the pressure around the wellbore as function of time مع الوقت. So as we away from the wellbore, we have high pressures. As you come close to the wellbore, the pressure will be depleted and gets more and smaller. The pressure here at the end نسميه PR or PE أحيانا external pressures. ال PR بالوسطى هنا PR الخدش line, and the pressure inside the wellbore نسميه PWF. More precise, ال PWF تقدر تسميه PWF أو PWF و S معها, and that's mean near the perforations. فال PWF تقسمها قسمين. قبل ال perforation يسمونه PWF S. داخل الويلبور يعني عبر perforation نسميه PWF ما به S. To be differentiated. منو أكبر؟ ال PWF S أكبر من ال PWF يعني دلتا P because I lose the pressure due to restrictions. هذا كلها بعملية flow of oil in porous media. To understand optimization حتى تعرف هاي الشغلات، حتى تعرف أنا أقدر أعمل optimization أو ما أقدر. وإذا أنا إذا كبر ال PWF لازم أعمل مثلا acidizing or increase number of preparations and so on. Because optimization هي you need to produce more oil with minimum cost. فأنا عندي ال unsteady قلنا إلى عاملين position and time. هذا الكيرف underneath in this slide. شوف هذا الكيرفات هذه لها علاقة بالتي فاكتور T5 T ولها علاقة بالposition R. So you have a trend of a pressure يعني ما بين البعيد إلى الطرف القريب من الويلبور على assumption that flow rate Q is constant. فأنت عندك ال dB by dt is function of time and position. يعني not a constant بال unsteady state. بال steady state constant. بال unsteady state not constant. أكو ما يسمى pseudo steady state which is semi steady state sometimes يشبه semi steady state هو يعني لا هو steady ولا هو unsteady. In this case it is in the middle. وهذه عادة الحين نقول ال dB by dt إله أيضا constant depending on the location of R. To be more precise, which is I don't like as a reservoir engineer, مرات حنقول ال dB by dt equal to 0 وهو مستحيل ال dB by dt equal to 0. نانا بالsteady state ذولي نظريا theory يقولون يساوي 0. هو ما يساوي 0. يقول 0.002 مثلا psi per minute or per day or per hour. هم يقولون constant او 0 فنقول constant احسن. فانا اقول ان انا مثلا هم يقولون 0 احيانا بالsteady state 0 بالsemi steady state is function of I and T والسيدو اللي هو semi steady state يقول هو عبارة عن constant dB by dt. ليش أنا I'm talking about production engineering. Why I'm talking about reservoir? because they said to understand production and to understand optimization, you have to understand your reservoir. Then in production optimization, two factors you need to look into. One of them, flow in porous media, يسمينا IPR. IPR, a flow inside the rock, that's mean reservoir. الجزء الآخر يسمونه outflow, اللي هو flow inside the production tubing. فالoptimization إلى علاقة بالطرفين. Optimization in my reservoir and optimization in my well bore and the surface conditions. So I need to know these things. That's why I'm teaching you this.
Excuse me, I have a question, please.
You can ask, yeah.
Yeah, regarding the unsteady state, please, if you go back to the previous slide. No, just the previous one. Yeah. No, yeah. So I think 20, slide 20. Yeah, so you said we have PWF and PWFS. What does these two terms stand for, please?
Okay. بالسلايد الأول أول ما سلايد بالsystem and the production system, and this slide if I make it large for you, عندي P شوف هذا الصغير داخل مربع PWFS. You see this one? And عندي PWF. You see it or no?
Yeah, I do.
The pressure just before the perforation, at the face of the perforation, نسميه PWFS. بعد يعني الأويل يا دوب جاي يدخل من الفورميشن inside the wellbore.
Sand face pressure, right?
نسميه sand face. نعم. Once inside the wellbore يصير PWF. فأنا عندي شوية دلتا بي بيناتهم. الدلتا بي مالتي هي دلتا بي نمبر 2 هنا. Loss across completion, loss pressure across the perforations.
Yeah, so PWF stands for flowing well pressure, right?
PWF ما بيها S flowing well pressures. اللي فيها S the pressure inside the rock but at the entrance of the perforation.
Okay, so do you have static well pressure?
ما عندنا إذا بالفلو ما عندك static. If you close the well bore يصير عندك static.
Okay, cheers.
If you close the well bore يصير bottom hole pressure. يتحول من PWF إلى BHP. If you close the well bore. فأنت عندك static حقيقة بس indirectly PWF أكثر من static اللي هو rho GH. So it's pushing up. And therefore you have natural flow. إذا ما عندك flow, yes, you will be having some static head. أرجو أنه جاوبتك. Yes?
Yes, you did. Thank you.
Thank you. So go back again to my slides. We have steady state, semi-steady state, and the unsteady state. And both these regimes are important to be understood in order to understand my IPR. Remember, with optimization, I'm talking about optimization. You have two criteria. One inside the rock, and that's very much reservoir. In this case, we ask ourselves, what the flow regime is: steady, semi-steady, or unsteady? The semi-steady هيسمونه pseudo. بالsemi-steady اللي هو pseudo أو pseudo steady state, the P silent. You may derive your Darcy equation in other words, and you say, for example, I take the middle line. I take the natural log at the middle of the RE. Well, if you have a calculator, a natural log of 0.47 is equal to 0.75, I think. And that's coming from that natural log of the 0.47. I just want to switch on the light. And I bring my calculator. If I say I have 0.47 يعني تقريبا منتصف الطريق. أقول natural log مالتها natural of 0.47 0.47 should be a negative value. Yes, negative 0.75. إذا عندك calculator وتاخذ الناتشرال لوج ال of 0.471 يعطيك هذا minus 0.75. How they took it? They said we take the halfway through. يعني from PE هذه المسافة من PE إلى PWF آخر نصف الطريق الافرج اسميه اللي حوالي 0.47 تقدر تاخذ 0.5 إذا تريد ما يخالف ماكو مشكلة و take the natural log of it. So you modify equation اللي هي من steady state to semi steady state and this is the equation now. نفس هي مال Darcy equation but بها new factor اللي هو negative 0.75. Modification of Darcy equation radial to fit the title of semi steady state. واللي هي most common يعني هو ماكو steady state حقيقة. In nature difficult أن تاخذ semi steady يعني steady states difficult. So semi is more obvious. And you develop this equation later on as يعني you just develop the equation as a subject of time factor or something else because you need to come with how can I predict the value of my PWF. Very important in optimization. إذا ما عندك PWF I'm asking you ما عندك PWF. Here PWF is nil, zero. Do you have production? No production. So therefore, to predict the PWF, you have to put an equation, and this is the equation in semi-steady state to predict the value of PWF. Important in optimization. ما عندك PWF ما عندك production. So you need to know it. With time of flow in hours, and also we need to know it in terms of RE, how far away from the PWF, from the wellbore. عندك هاي data تقدر تسويها later on. بالsteady state also to be more precise بالsemi state you have to think about the shape factor A. يسمونه shape factor CA والA هي area of the drainage area. والshape factor يعني قد تكون square, circle, triangle, whatever. Also that's important to take in consideration. So what I want to say from here, I'm talking about optimization. To do production optimization, you deal with two areas. Area number one is the reservoir. And then from the reservoir, you say it's a steady state, semi, or it is unsteady state. I prefer to go to semi. Semi is more common. And therefore, I need to develop, modify Darcy equation to suit لكي تناسب البسيدو أو السيدو. And that's very important. And then I have done the first part, understanding reservoir. I still talk more about reservoir a little bit, and then I talk about the tubing. One of the enemy for production optimization is the issue of يعني restriction of flow, especially if you have a blockage in the rocks because of skin factor. Because of a skin factor. Or because of a blockage in permeability, because of pressure losses. So أنا عندي مشكلة بالIPR هذه مشكلة بالreservoir. So I need to know why. Why I don't have flow in the rocks? You question yourself. So put a solution and maybe reservoir simulation can help you. إذا كان skin factor as a reason behind that, so you need to know how to calculate the skin factor. You need to know how to do it. You need to check that you have skin and how much is it. The skin positive, مشكلة, not good. The skin negative or equal to 0 is good. Positive small, okay, but positive large, مشكلة. I'm sure again, some of you is aware about the skin factor. Can I add skin in the equation? Yes, you modify equation and put S inside it in order to be more real. This is in steady state as well, also in semi-steady state. So my message is like this. I want to understand optimization. I repeat myself again. One item, I need to understand my reservoir, my Darcy equation, my flow behavior, and the restriction there. So that's important to keep in mind. Now I come inside the wellbore. Now, in this slide, I am inside the wellbore. The oil needs to be lifted up to the surface, either by natural flow, in which case natural flow تقول in case of if I have something here, I say natural flow usually happen إذا كان عندي ال PWF larger than the P static head, weight of the column. One of you سألني قبل شوية من قال عندي static head, static pressure. So I have to have a good pressure inside the wellbore to lift the oil up. هنسميه natural flow. Natural because I don't use any pump. I don't use any gas lift. من nature يعني من طبيعة. Reservoir natural like that. Allah subhanahu wa ta'ala be nature والماء والoil go to the surface. لا أنا ما عندي period زين مو هواي و I need to produce more. So I use artificial lift. Maybe including ESB, أقدر أضيف أنا water flooding, CO2 flooding, whatever, and in order to get some kind more pressure, in order to make BWF a bit large. فأنا بالإضافة للartificial أقدر أخلي كلمة ESB أيضا ESP gas lift as well. ESB stand for electrical submersible pumps, مضخات كهربائية غاطسة. I'm planning to give a seminar on a webinar on ESB and gas lift, inshallah, in near future. It's a good topic. Then flow in tubing حنسميه أيضا lifting. Natural gas lift pump إلى آخره. و flow inside the wellbore inside the tubing now. والفلو مالتي هل هو single or multiple phase. These are important to know to do the optimization. عندنا flow in the wellbore يعني قبل لا يدخل التيوبينج or the flow in the tubing اللي حنسميه outflow والflow is it single phase or multiple phase, oil, gas and water. Especially if I have pressure less than bubble point pressure, I may have some multiple phase flow. I will show you that later in the tubing. أرجو أن يكون ذاك واضح. Remember these things. إذا أنا خلصت من الريزرفوار and I now inside the wellbore. Inside the wellbore, flow from reservoir inside it, and then from inside to the tubing, production tubing. بعدين transportation. Now the oil come to the surface. So remember, I'm talking about the production system, shabab. I'm talking about the production system, this system. So I have flow between 8 and 7 سميته IPR. 7 to 6 سميته flow inside the wellbore. From 6 until 3 سميته flow in the tubing, outflow. From 3 to 1 سميته pipe system, transportation. Then from 1 to 1B سميته surface pipeline. So these are important to remember in terms of production optimization. إذا كان البايبلاين عندي, I'm asking, how can I make the flow rate in the surface very optimized? ما في مشاكل. الجواب, I will use large diameter pipeline, smooth pipeline, no roughness, very clean pipeline, no restrictions, no valves, no bending, no elbows, no tees, T's يعني T connections, so it is a wonderful flow. ما أبي أي restriction. يعني لو تسألني أنا تقول لي أنا عندي بايب لاين دكتور حسين، شلون أخلي البايب لاين مالتي optimize والفلو بي ما بي restrictions wonderful. I tell you, use the right diameter, should be very smooth inside pipeline. It should be clean pipeline, no scale, no any asphaltene or tar. Don't put any valves on it. Make it a straight pipeline with no elbows, no any bending, no any T connections. So this is give you an optimum flow. بعدين من البايبلاين يروح التانكرز ويروح لي other places. So this is important for me to consider. For flow and pipelines, I need to understand the pipe component. مثل ما قلت الvalves, الelbows, the T's, the pressure gauge, flow meters. I need to know these things. Diameter, thickness, length, flow control and conditioning. So you need to adjust the flow rate through a certain valves, نسميه control valves. Some people call it globe valves. Globe valves are very good for control. Ball valves is good for sealing. Separator, I need to understand my separator. Do I need it or not need it as well sometime? And the pressure maintenance. How can I maintain the pressure from 0.1 to 0.5? Shall I use a pump or compressor for gas? In certain countries, for example, in Abu Dhabi, in Oman, I have seen that they put the tank on a hill, منطقة جبلية عالية, and the flow comes with gravity sometimes to minimize the costing of running a pump. So that's also important in transportation. Remember, I'm talking about subsurface, غطيته لكم أنا, reservoir داسي إلى آخره. Now we come to the outflow اللي هو inside the bottom of the well bore, the production tubing, وصلنا إلى التشوك السبريتر، من السبريتر طلع إلى البايبلاين system. One of the technique they use to understand production system optimization technique يسمونه nodal analysis. النود هو الجنكشن. When does the outflow مع الانفلو يرتبطون نقطة معينة نسميها نود NODE. نود يعني الجنكشن, the roundabout in the roads in this case. هذا أحسن طريقة لاختيار ما يسمى عملية الأوبتمايزيشن. يعني لو أنا أرجع إلى هذا السلايد أمامك, I am asking you from these numbers, number 1, 2, 3, 4, 5, 6, 7, 8, which number you think will be a good node? يعني بنص الطريق, لا منا ولا منا. يا number. Somebody can answer me. محمد نوري. Can you جاوب me? محمد نوري. حسين حمزة. إيه محمد نوري سولف. حسين حمزة, can you answer me?
Sorry, what was the question again?
So أنت ما كنت معي. From this system in front of you, number 8, 7, 6, 5, 4, 2, 3, 1. يا number منهم تاخذه عبارة عن roundabout, a good joint. It is the node. يعني لا هو على اليمين ولا هو على اليسار, صار بالوسط. نفس الطريقة.
Sorry, Doctor, can I answer you?
Yes, عقيل, تفضل.
Yeah, I think the 0.3 is a good node.
0.3 بالسيرفس اللي هو الهيد عندك.
Yeah.
اوكي, تقدر تاخذها, بس انا اقول احسن شيء هو 0.6. يعني 0.6 ما بين الاوت فلو وما بين انفلو. 0.6 صار بالوسط ما بين فلو in the reservoir والفلو in the tubing. فهي a joint which is between inflow outflow. They can't take number 3 as a wellhead pressure if you want to deal between 1 and 6. Don't include 7 and 8. But if you want to include all of them from 1 to 8, I prefer number 6. عزيزي جوابك صحيح أنت. You answered the question correctly. If you choose number 3 as a wellhead, and therefore you will be a node between 1 and 6. But if you want from 8 and 1 and 8, you have to choose number 6. This is the meaning of node. The meaning of node, like a roundabout. Something in the middle between flow in porous media and the flow in the tubing. That's something you need to remember. And I hope that the beginning of optimization, you choose a point and you say, I play the game around it. How can I optimize my pressure in this case? We call it in this case production outflow. Keynote optimization, sometimes they write it with Z letter, optimization, sometimes write with S letter. American people use Z, English people use S. So same spelling. Karina, what do they say in Spanish? Optimization. No idea?
Optimización.
Okay,
Optimización de la yeah, is
better leave it in English, please. Leave it in English, easy for us. Thank you very much. Thank you, Karina. So the optimization is something, as I said, optimum. Optimum يعني typical, ideal, with minimum losses and maximum production. And therefore, I need to balance between 2 flow. One of them, I name it inflow. Between 8 and 7, I name it inflow, IPR, inside the reservoir, according to Darcy equation and according to Vogel equation. And between 6 and 1, I name it outflow, outflow. So can I balance between inflow and outflow? If the answer I can balance, then this is optimization, the beginning of optimization. Very simple for a production engineer to take that in consideration. Whether sometimes you use ESB or no ESB, same idea in this case. So production outflow is a production of oil moving through the tubing, through the choke, through the flow line until the separator. And that's something which is you need to take in consideration. Production tubing is important part in optimization. If you choose the right tubing, right diameter, and right location as well, and right numbers. Why numbers? Sometimes you have only 1 tubing in single completion. Sometimes you have 2. Sometimes you have 3. We call dual completion and triple completion. And sometimes multilaterals. So remember, my friend, all of you remember, the most important part within the oil well, which has a connection with optimization, is the production tubing. Production tubing. The other important part in the wellbore and has a good connection with optimization is the wellbore perforations. Wellbore perforations. So perforation, tubing, very important of optimization. Number 3 is the choke. Choke. The choke also play important part in optimization. Choke size, close, semi-close, no choke at all, also important to think about optimization. So regarding the tubing is very important part in optimization, especially diameter of it and number of these tubings which need to be looked into and considered. I'm just worried about the time. I got with you about 20 minutes and then I have to stop, 22 minutes and then question and answer. Let me talk a little bit about production tubing. Very important part. Should be integral, clean, no any holes, no corrosion in it. It's set very well inside the wellbore, a good packer to fix it, to put it somewhere, and no any bending, no any blockage, and so on. All these are important in production optimization. Can I calculate the diameter of the perforation? Yes. Somebody gave us equation like that. If you know the length of the tubing, flow rate, you know it. PWF and PWH. PWF is the pressure number 6. Number 6 here in this diagram is PWF. PWH is number 3. Number 3. Can I know them? Yes, you can know. You can measure them actually. You can measure them. So you know the pressure, PWF, PWH. You know the length of the wellbore, gamma, the specific gravity of the oil from the API. You can use the equation in front of you to predict the typical diameter for the tubing. So if you know the diameter, then you will be, I can say, reasonably happy to choose a good one for optimization. So it gives you a number plus minus. So somebody put the equation for us. Tubing, it could be vertical, the easy one. It could be in deviated wellbore. It could be in horizontal wellbores. But at the end of the day, will be almost same principle. In horizontal, we have some challenges regarding the segregation and the gravity factors, but in vertical and deviated could be the same. So optimization, the other question they will ask you, is your wellbore vertical? Most of the wellbores in Iraq are vertical or maybe horizontal, but most of the 70% of them are vertical. So it's an easy one. The vertical, they will ask you the flow patterns or the flow regime in a vertical tubing. Is it at the bottom, single phase? As you go up from the PWF through the number 6, 5, 4 until you reach number 3, the pressure will be depleted. The gas will come out of the oil. You see these red spots? The red spots are coming larger and larger and larger until you finish with a wellbore with mainly red. Most of it is red. And that's something you need to keep in mind. That flow inside the production tubing from a single phase to a multi-phase to a slug flow, it has an impact on a friction. If the friction is very high in the tubing, the flow rate will be very small. So it is against optimization. I'm asking you, how can I reduce the red area? The answer in 2 ways. Either you close the choke valve half and half to put back pressure, so no more gas coming out, or you increase the pressure in the reservoir by using water injection, and therefore you will not get gas out. The gas will come out of the oil because of the bubble point pressure. So how can I make the bubble point pressure is avoidable? 2 ways. Choke, don't make it fully open. Number 2, if you can, do water injection to build up the pressure of the reservoir. This is optimization. I did mention water injection about optimization in the first slide, I think. If you remember, I mentioned that as something to consider. Consideration, I think I mentioned that. I'm sure I mentioned the water injection, gas injection, and so on. In order, here it is, complex water injection. Sometime I need to do that.
Sorry, Doctor, a quick question, please.
Yes.
For the reason 1, the full choke open, what is the effect on this choice?
If you make the choke is fully open, you make a big drop in the pressure of the wellbore. There's no back pressure at all. If the pressure in the wellbore drops and become less than the bubble point pressure, they will get more gas. And sometimes could be these gas could be make a choke or a gas lock, L-O-C-K, locking, because احنا نقول عنه بالعربي يختنق, تخنقه, because of too much gas. Did I answer you? You also next. You have more questions to ask? Yes, you okay? So remember now, I'm talking about the other part of optimization. I finished the Inflow, Darcy equation, steady state, semi-steady state, unsteady state. I mentioned IPR. I mentioned Google equations. Now we are inside the well bore through the tubing. Tubing, this is the patterns of it. And this is the mathematical equation to know how much pressure I drop. The most enemy for optimization is the pressure losses in the production tubing. The more I lose the pressure, the more I am away from optimization. Why do I lose the pressure in the tubing? According to, if you remember in physics or in fluid mechanics, they talk of Bernoulli equation. Bernoulli equation. This is Bernoulli equation. I have three energies: kinetic energy, dynamic energy, and position energy. Some may call them static energy or wellhead energy or static head. These could be influencing how much I'm losing. Beside F is the friction losses, called dynamic, the length, the diameter, and so on, and U is the velocities. L, in this case, it tells me the deeper the well bore, the more the pressure I lose. The difficult for optimization. Shallow is easy to optimize. And the friction losses, depending on diameter of the pipeline. Small diameter is more F. Number two, it depending on roughness of the pipeline. A smooth pipeline, small f. And number three, it depending on Reynolds number, whether it is turbulent flow or laminar. Laminar flow will give me less friction losses. So you need to think that way. You are a production engineer, say, how can I make it laminar? How can I make it smooth pipeline? How can I reduce the frictions inside the pipeline by using a good diameter for my tubing? These are things you need to think about as engineer. You should ask yourself, I am production engineer and my company asks me to do optimization. What shall I do? I remove a skin factor. Maybe I do more perforations. I do maybe hydrophilic fracturing inside the rocks to give me more flow. Inside the tube, inside the well bores, I have to make it very clean, no sand production. The production tubing should be clear, clean, no restrictions, no any scale, no asphaltene buildup. So should be smooth, the right diameters. Should be the flow is single flow, no turbulence, no multi-phase flow. The flow should be laminar. Laminar means Reynolds number less than 2001. So all these things you need to think with yourself and question yourself. This will help you to do optimization. Yani you change theory into practical. That's the job for optimization production engineer. And maybe I assume some of you already is a production engineer in some certain outcomes. So the outflow, you need to think about Bernoulli equation and the calculation. Friction factor is important to be predicted and to be calculated using this equation. Or sometimes they use they call the Moody diagram. If you remember, in fluid mechanics, they do Reynolds number and the roughness and the Moody diagram, which is you have done in the university maybe a long time ago. I move a bit faster because these are very, very theory things. Now, my question, what can be done to improve the outflow rate? I mentioned to you, reduce friction losses, use a larger production tubing. Don't put restriction on the choke size. Make the choke size a bit 3/4 open, for example. These are important, no restrictions. And the other question or the other answer, maybe I will use some artificial lift, such as maybe gas lift or other things, slowing friction pressure drop, larger tubing, lower friction pressures. Choke, why choke is needed? Sometimes I know, and when I was to go to Abu Dhabi at NOC, in certain wells they have no choke, zero choke. They remove totally, no restrictions. That's the way they think in order not to put any back pressure on my wellbore. And I remember when I was working in Rumaila oil field, south of Iraq, long time ago, we have some wells with no choke on them, especially if production rate is very high. So these are things to consider in optimization: tubing and choke, tubing restriction and choke size, and that's important. Nodal analysis can help very much a lot. Take a look at a point I call it node, N-O-D-E, between inflow, between the rock, and between the outflow. And in this case, I can name it in this diagram as the PWF. If I say this is 8 and this is 7, it will be number 6. And from there, I can use it as a pressure before and after, and balance the equation will help it to put a node in this case. Nodal analysis help you a lot to find exactly production tubing size and the number of perforation you need. That's very useful actually. So remember, one of the tools could be used in order to do optimization is nodal analysis. Maybe something you have done in the university, not something else you have done in the now, but nodal is a good tool, a good technique, a good analysis in order to predict the optimization which need to be changed. Shall I change the tubing? Shall I put an ESB? Shall I use a gas lift? Shall I increase the number of perforations? Shall I open the choke? Nodal analysis can tackle these issues. And the idea, for example, here I have between PI, P separating, and P separator. This could be a node area between the bottom to the bottom. I is 1 and P separator is 8. So, for example, in this example I put here between inflow and outflow, I put a junction node as PWF, which is at the bottom of the wellbore. Before that, I have PI, I have PR, and I have PWFS. So I can say I have 8, 7, and 6. Some people say just 8 at the They say 8, 7, and 6 in the middle, in the beginning, in the middle. But I can say 8, 7, and 6, and then I can put 5 here. On the top of it, I have pressure in the tubing, wellhead pressure, and the separators. If I can make a balance between them, so equation number 1, this is the way you write it. And equation number 2, this is the way I write it. And in mathematics, you say equation 1 equal to equation number 2. Substitute the numbers, and you find the optimum pressure for PWF later on as a solution. I'm not teaching nodal analysis here, I'm to optimization, and my time is very, very bad because I forget myself talking and the time running fast. But this is the principle. Yani to give nodal analysis, maybe in the future I'll give a full webinar on nodal analysis. I gave a full course, 5 days course on nodal analysis 2 months ago. It's a big subject and need, but this is the principle of it. I will teach, I'm sure, I promise you, hopefully when I get the time, I will arrange a free webinar on nodal analysis. So the production system, you need to design a production system never to be separated into reservoir and piping system. It's one system altogether. And include the reservoir, subsurface, and include the surface. It will look into about oil and gas flow in the well, from the reservoir, and from the wellbore to the separator. The entire production system must be analyzed as one unit. We take it as one unit altogether. From the reservoir, even you reach the stock tank. It's one system. So what do I need to do for optimization? What's the procedure for optimization? This is the about 8 points, 8 steps. Step number 1, name a component in the system. I say the wellhead, PWH, or maybe I say PWF. I choose something. Select one component to be optimized. I am optimizing the production tubing, or I am optimizing the choke size, or the number of perforations. By the way, you can optimize three things in general: either the production tubing diameter, or the number of perforation, or the choke size. These, if you optimize them, you get reasonable understanding for optimization. You may add other factors. You may add the restriction inside the well, restriction in the tubing. You may add the SSSV, subsurface safety valve. You may use that one if you want. But as a general, easy way, think about perforation, number of perforation. Think about the choke size or pressure of the choke, and think about production tubing diameter. These are good areas to analyze for optimization. Select a node. As we said, for example, the node is the junction between before and after. Before and after. PWF is a good one. PWH also a good one. These two areas good. PWF or PWH. They are good nodes. Develop the inflow and outflow. Remember Vogel equation, the IPR, the J factor, and the outflow, the friction losses and the tubing. Calculate the pressure drop, delta P. Effect of changing the pressure drop at 3-inch tubing. How much? And I repeat, same calculation at production tubing of 3.5-inch. And how much? Pressure drop at a choke size, for example, half open, and pressure drop at 3/4 open. So this, if you can make comparison in this case. That's the meaning of changing by selecting a component. Repeat the procedure for each component and optimize the production system according to, say, this is the optimal. These are steps used in nodal analysis, which is a tool to do optimization. The procedure. For nodal analysis, the solution for that, an important tool for this, at the end, because it has a connection with the deliverability of a well, delivering oil to the surface, nodal analysis can help. So you put the system in front of you. I make it large. You can see it now better. I prefer, if you ask me, what do you prefer? I prefer two areas for nodals, either PWF and before and after, or آخر the wellhead, or maybe the choke. I can take the choke. This is the choke here. Will help. And I make the equation like that. I have some examples for calculation, but I thought today's webinar, not a lecture. So I don't want to do calculation, and the time is getting tight on me. My lecture is oil and gas production optimization. I covered most of things on oil, but I didn't talk about gas. I will talk a little bit about gas. I like gas reservoir very much. This is the logo of my company anyway in Liverpool. We have the in gas reservoir, you have a gas bed, piece of the rock with gas inside it. And the best way to get it out is horizontal drillings, wells. The main challenge in gas reservoir is the low permeability, very tight compared with oil reservoir. And the pressure depletion is very fast compared to oil. Sometimes gas reservoir need fracturing more than the oil reservoir. So there's difference between them. So you need to understand gas reservoir a flow of gas through porous media and the type of the flow. Sometimes you have only gas, dry, sometimes gas will condensate, which is more difficult, especially if you have bubble point pressure small and the condensate come out. You need to also be aware about how much gas in place I have, the gas equivalent in standard cubic feet. This is the way to calculate it. GE, gas equivalent in standard cubic feet, especially in gas condensate. And also you need to be aware about total gas produced, GP, because that will give you an idea about depletion pressure. You need to, in the reservoir as well, to do how can I estimate how much gas in a place before production. They use the graphical way, before and after production, and recovery factor between the GP over GI initial, or they use equation, simple equation, they call the volumetric equation. This is the volume equation to predict how much gas you have in the reservoir when you bring it to the surface. Because you have BGI. BGI, we call it gas formation volume factor. Sometimes they call it expansion factor. Quite useful to have a little background about gas reservoir to do the optimization later on. The major things in optimization is to control the pressure. The pressure depletion rate in the gas reservoir is much higher than depletion rate in oil reservoir. Same thing, you have radial and you have linear. You can use the radial model for the gas production. So therefore, the pressure is important. PWF is very important because depleted very, very fast. So that's why we have square factor. So in radial or also in linear, square. And use the RMS, root mean square, to take the average between P1 and P2, between PR and PWF. Viscosity of the gas is very small. Z factor also need to calculate. So to understand optimization in gas production, keep an eye on the pressure. The pressure depletes very fast. This is the equations, both linear and radial. And how much do I recover at the end of the day? How much I can produce? 90%, 95%? This is the way I calculate it. So they give us equation to calculate the final recovery factor. So you need to know that as well of optimization, because optimization means you need to have R factor as big as possible. 80%, 85, 90, 95. That's important in optimization because I need to produce as much as I can with minimum effort and minimum money I need to think about. So understand reservoir is important. The time, I hate the time. Now we have nodal analysis. I mentioned that the node. These some examples of pressure drop with being outflow and inflow. This curve coming from the pressure down, hence I mean IPR. Sometimes a J factor, inflow. Relationship between the pressure drop with the flow rate. So the more pressure I drop inside the reservoir, the more flow I get. In the tubing, the more pressure I put in the tubing, the more flow coming out of it. So maybe an ESP, maybe high pressure of PWF. So more PWF, more Q. Less pressure, reduction inside the reservoir, more Q is coming. The intercept point between outflow and inflow احنا نسميها the optimization point, the best operating point. I can get a best flow with a best pressure. How can I control the pressure in PWF? By controlling the pressure in the choke, by back pressures. So this is an idea of optimization between inflow and outflow. Of course, you need data. You need two tables of data. One table between the PWF and the flow and the tubing, and the other one between PR and the pressure inside and the flow rate inside the reservoir. So one is Google equation, and the other one is the outflow in a pipeline. So one of them is Google, and the other one is the outflow. So Nodal is very good. Intersection between inflow and outflow can give you the understanding for optimization. You go back again to the system, which I repeat the system very much, and you choose a node, and according to that, you optimize. You see, in this system, I will enlarge for you now. I enlarge it for you. You choose PWH as a node. You choose this one, PWH, as a node. Before and after. Before PWH, he had this equation: reservoir minus pressure drop in the reservoir minus the pressure in the pressure drop in the tubing equal to PWH. So to reach PWH from bottom up, just follow this. Bottom up. آخذ PR. I take PR. I take PR delta P reservoir. اللي هو I lost pressure inside the reservoir due to restriction. And then I took the pressure losses inside the tubing, P delta V. A tubing between PWF until I reach PWH. The pressure I lost inside the tubing because of friction losses, because of Bernoulli, gravity, position, dynamic. The pressure I lost in the reservoir because of restricted permeability, small permeabilities, no good movement, maybe because of skin, maybe. That's equation number one. Equation number two is the outflow. The outflow is between separator and flow line. He said, I have pressure of the separator and the pressure in the flow line. He add them together because they are adding, because I move opposite way to get the PWH. So from bottom up, you take a negative, minus, minus. From separator to wellhead, you add, mathematics-wise. Just think about mathematics. You agree with me, PWH is adding of separator plus the pressure loss in the choke or in the flow line. It's come to this one. But this one came because I lost the pressure from reservoir into the surface. And that's something you need to take in consideration. I hope that's clear, or I can say simple in that way. If you put them together, you find a solution later on. Here about diameter of the tubing. D1 smaller than D2. When he increased D2, diameter of the tube is larger, he gets more flow rate on the x-axis with the almost same delta B or small delta B. This is for diameter. So these factors you need to think about flow. I will open the chance for question and answer. This is another nodal analysis. This is nodal analysis. Tubing optimization, we mentioned that already. If tubing optimization can get it easily, as we say, between inflow and outflow interception point. Tubing, we have mentioned tubing. Perforation also. The more the number of perforation, the more the flow rate, the better optimization. So I have also inflow and outflow. N number. So N3 is more than N2, give me more flow rate. N1 small, N2 larger, middle, N3 more. So the more the number of perforation, the less restriction, the more flow rate. Optimization. So optimization number 1, an increase production tubing. Number 2, an increased number of perforation from this. Of course, in mass balance, choke. The choke also important in calculating the J factor. I need to come to the choke. Tubing I mentioned, it's a choke. The chokes are important to be fully open and good condition in this case. So the choke valve is important. I can get more rate, will have a bit larger opening for the choke, more flow rate. Between D1, D2, and D3 for same delta B. You can also the IPR inside the red line and the flow inside the rock. The TBR, a tubing performance relationship inside the production tubing. The interception also could be give you optimization. This is for the choke. I'm passing very fast because of the time, and I'm getting tired now talking about 1.5 hour more than that. So we have these delta B's, you analyze them. So you have to have a relationship between flow rate on the x-axis, pressure on the y-axis, and try to compare between them. There's no choke. What shall I have? Surface wellhead, choke performance. You have the IPR in flow. This interception point is the optimum point between the surface wellhead flowing pressure, that means between the wellhead and the separator, and you have the choke. It gives you the optimum choke size later on. So the optimization, think about tubing, flow line, the back gravel path, and so on. These are important, like communication. This is with ESB or gas lift and so on, hose effect. I'm passing very fast because of time and because I need to answer you. So the forecasting as well, maybe I will give a lecture some other time. So you think about future time. You can predict in the future how much I can do regarding wellhead pressure or choke size, or maybe shall I change the tubing to something larger or no? And very, very important thing about it. So in conclusion, I can say that nodal analysis is a technique for optimizing choke, production, number of operations, and these are important in optimization. It is widely used in industry, this nodal analysis. You have a software nowadays, you have put data, and the computer can give you data, such as the simulation or the performance, etc. And these analysis data is very useful. Okay. I started with you. I know in your time, Iraqi time, and maybe now you have 10:43. You are fed up with me. Yes? Did I make you a bit upset with talking too much? This is the job of a teacher. You want to be a teacher, you have to be a good talking abilities. Otherwise, keep quiet. Okay. So now, Abdullah, if you hear me, can you read for me the questions on the, or anybody want to ask me? I don't know. I can read some of the questions here written for me in the chat box. Ahmad, he said, Salam alaikum, alaikum Ahmad, alaikum salam Ahmad. And Ari, Adam, hello everyone, hello Adam. حسين السلام عليكم.
السلام عليكم أستاذ.
عليكم السلام، تفضل.
أستاذ، نقدر نقول النودال أناليسيس هو نفس السيموليشن
لا. Simulation is when you put some data in a program, set softwares. The data you put in that software, some of them called static data and dynamic data. You collect from the reservoir, from the flow, you put them together, and you tell him, can you analyze for me, and to tell me what is the right production size, for example. So it is a tool to do analysis. The analysis best to be done first by annual hand work, and then if you have enough data, feed that data into a software to solve the problem. So simulation is something else actually, and there are so many types of simulation nowadays, but simulation is solving the nodal analysis if you have the data. I prefer for a starter شخص تو مبتدئ is to do it by hand, to put the system in front of him and do it by hand. That's what I prefer, because it make you understand things much better in this case.
شكرا استاذ. واستاذ عندي سؤال اخر. هذا الموضوع البرودكشن اوبتمايزيشن كان مشروع تخرجي، بس هو كان optimization production of oil well by using Prosper software، وانا استخدمت الاي اس بي بامب استاذ. فقدرنا يعني بعد ما استخدمنا الاي اس بي قدرنا تقريبا الانتاج ازداد تقريبا 2000 barrel per day.
Very good, very good. Yes, it is clearly, I agree with you. If you do good nodal analysis, if you choose the right tubing, the right, I can say, system, it will increase the production for sure. Yeah, that's the idea of optimization, is to produce more oil with minimum pressure drop and minimum costing.
شكرا استاذ على المحاضرة، أنا كلش استفادت.
الحمد لله آري، شكرا آري.
مشكور استاذ.
حياك. Any more question to ask, or shall I read?
Yeah, Doctor, I want to thank you about this awesome session, and for your answer about my question. I lost my network, sorry. My question was about the closed shock valve. Yeah, what is the effect of closed shock valve? It is the slippage velocity, can effect of that, or what? Thank you.
Yes, slip velocity will be affected. Yes, if you closing the choke valve from, for example, fully open to 3/4 to a half to a quarter, you put restriction on flow. The flow cannot come out of it. So in other words, you put back pressure, الضغط العكسي. You are pushing the oil inside the wellbore, and therefore that's the major aim. It will decrease the production. يقلل الإنتاج. يعني if I bring this slide, for example, the system slide, where I have the full system of production like this, and number 3, I'm closing, assuming we have flowing wellbores. So I put restriction in this. I put back pressure on the top of the oil. It cannot come out easily. So yes, back pressure by closing the choke, it can reduce the slip velocity. It may also put back pressure on the wellbore itself, on the perforation area, and the production will be reduced in this case. Sometimes we need to do that if there's too much gas coming. I don't like gas, so maybe back pressure on the choke could be useful to reduce the amount of the gas released. I hope I answer you. Yes?
Yeah, thank you very much, Doctor.
حياك الله عقيل. If I read Ahmed, Muhammad, Yunus, Assalamu alaikum, Dr. So thank you, Muhammad, Yunus. Sukra, كم دقيقة 7. There's no question, only comment. Abdullah asking about the links for the attendees. Sukra asked about certificate. Ahmed asked about how many lectures later on. This is a Karbala University issue. I'm reading very fast on the chat box. There's no very much there. semi study pseudo study ثابتة بعد اضطراب. Yes, it will be dB by dt is constant. I mentioned that already. محاضرات ماكو يم صوت موجود. So I'm finishing the chat box, assuming that you have understood me quite well. Muhammad asked question. Dua is about water injection. Yes, water injection has some impact on optimization because build the pressure of the reservoir. PRS العالي عندك. So yes, dua, water injection is complex but useful for optimization. Muhammad say, how can we do optimization in natural fracture well and ESB well? In ESB, especially if you have low pressure in the reservoir or WF small, heavy oil or static head is more, ESB can increase the production, so it could be a good idea for optimization, but costs you money because to run them. And natural fractures is a problem. Although sometimes it's good for easy flow because more permeability, I can say. But again, you can play the game with the choke and the production tubing. Second question, how can we choose the proper choke size? Depending on your GOR and multi-phase flow. With single phase flow, reduce the choke size. How left till you finish? Please, can you share? No. This is the site location. Muhammad Kazim. He already gave you the site location, which is very good of him. Copy link address. Rabat Tajin. Muhammad Kazim. I finished reading all the chat box. Nothing there actually. And I hope. تفضل.
دكتور حسين.
تفضل.
دكتور أنا عندي سؤال عن الآبار النفطية. مرة بمحاضرة حضرتها قلت لي نسبة الماء إذا ازداد عن 50% نحن ما ننتج من البير.
ايه هو حاليا مو 50% هو مو زين، بس بشكل عام اكو الدول تنتج حتى الى حد 60 65% حاليا.
فتعرف ليش؟ انه انا هنا شفت بير انه ينتجون نسبة الماء 80% وبعدين ينتجونه.
صحيح ينتجون لانه سعر النفط بالسوق price of oil is very good now. So depending on oil price. إذا كان price of the oil is small, there is no finance into it. اقتصاديا ما بي feasibility economic. ما بي But if the price of the oil is about $90, $95, $100, so yes, for example, لكل 100 barrels, 80 of them is water, 20 barrels is oil, so there's still good money into it. So the price of the oil in the market has effect on the decision of stopping or not stopping water cut high or low.
نعم، حتى انه ما كانوا يخلطون ويا النفط اللي تجي من الآبار الثانية.
نعم.
كان خلين عليه شركة سيرفيس باكيج.
نعم.
يصفي لهم النفط من المي بعدين يبعثونه للسي بي اف.
اي صحيح كلامك صحيح لانه يعني وان كان نفط قليل الاويل سمول but the price is very good. The price is very good.
تمام، يعني اذا سعر النفط عالي فعادي يعني ينتجون.
يعني economical factor. نعم عامل اقتصادي. نعم صحيح.
دكتور انه باي حاله نقدر نسوي هذا البير انه فور انجكشن نقدر نغيره انه يجي نسبه.
If you say now it's just too much water and I need water injection يتغير you have to change something in the wellhead assembly بحيث you connect a new injection pump so تغير wellhead could be stronger and better. Some people can change over the packer, but sometimes not much needed actually. All you need to integrate the wellhead. More expensive one is to put a new production tubing or injection tubing, but that's not always happening. So sometimes wellhead connected to a water injection pump sometimes is enough.
يعني عادي.
ايه عادي بس تغير الربط بدل ما عندك فلو لاين للانتاج يشيل فلو لاين وتربط انبوب اخر يشتغل بالعكس to inject water in the wellbore.
اوكي.
يعني تعكس العمليه من عمليه انتاج الى عمليه حقن.
تمام، يعني الفلو مالنا راح ينعكس اتجاهه.
Yes, that's right.
تمام، شكرا دكتور.
حياك الله. اوكي شباب. I will send the slides to our friend in SPE Karbala. If somebody want to contact me for more information, I will give you my email, and if you email me, I will answer you. This is my email. I thank you very much for listening. Today we have a good number, more than 90 something, 92. So I hope people being benefited, and we have all over the places actually, which is good as well. Okay, Abdullah from SBE Karbala, are you there? تسمعني Abdullah? Do you hear me? Where are you, Abdullah? Muhammad Kazim, are you there? SBE Karbala, are you there?
نعم دكتور تسمعني؟
أسمعك، تفضل محمد. حاول تختم الموضوع. Close this session.
شكرا جزيلا طبعا للحضور الكريم، وشكرا لك دكتور خالص الشكر، وإن شاء الله محاضراتنا مستمرة في هذا الكورس، وإن شاء الله يكون لنا مواعيد أخرى مع دكتور حسين. بالنسبة لأي أحد عنده سؤال يقدر يرفع إيده حاليا، وإذا ماكو فإن شاء الله ترسل المحاضرة وهي مسجلة وتنزل على قناة التليجرام SBE والBE أكاديمي.
أنتم
وشكرا جزيلا مرة ثانية.
كم محاضرة عندكم بهالكورس؟
حاليا 5، وإن شاء الله أكثر يجوزن خلال هذا الشهر التاسع.
different subjects ها؟
إن شاء الله.
Very good. يعني الشباب يسألون يقول كم محاضرة and so on. That's very good of you, and I wish you all the best إن شاء الله.
إن شاء الله. شكرا جزيلا دكتور.
مع السلامة.
مع السلامة، في أمان الله.
Bye-bye. I'm closing, and you may be closing as well. Okay, nice to see you. Thank you very much.
Thank you, Doctor. Thank you very much.
Thank you.
Thank you, Doctor.
حياك الله.